All right, characteristic 2, take another highlighter, horizontal and oblique asymptotes. And this is all based on which group it's in. Is the degree the same? Is the degree bigger in your numerator? Is the degree bigger in your denominator? In this one, I mean, you don't have to remember from before this was group 3, but you can if you want. You just have to know, hey, the degree is bigger in my denominator. That will always mean I have a horizontal asymptote at y equals 0. It's the easiest one. The textbook tries to give a nice complicated explanation, but you don't have to worry about it. As we go to extremes, as x gets very, very big, you're going to have a huge number on the bottom. Does it make sense? When you divide anything by a huge number, you're going to get close to 0. So, if the degree is bigger in the denominator, group 3, we have a horizontal asymptote at y equals 0. If, next example, the degree is the same. That will give you also a horizontal asymptote, and the horizontal asymptote will be at the coefficients of the biggest degree. Here the textbook goes into a nice complicated explanation with synthetic division. You can read it if you want to, but we don't have to worry about it. So, we have horizontal asymptote again. And if the degree is biggest in the numerator, and basically, I'm going to say, and there's no hole that simplifies it straight down to a line. Okay? This is where we're going to have an oblique asymptote. And we do need synthetic division to find our oblique asymptote. Okay? So, and I'll explain why it works. So if you had x squared divided by x plus 1, and you wanted to do synthetic division, do you see that your x squared has 1x squared, but 0 x's and 0 constants? You have to remember those zeros. And if you were dividing by x plus 1, you put a minus 1 out in front. We always brought down this first number. Negative 1 times 1 is negative 1, then added. Negative 1 times negative 1 is positive 1, then added. So we get as an answer x minus 1 with the remainder of positive 1. Your oblique asymptote is whatever you get with synthetic division, and you can ignore the remainder, even if it's something like 352 million. Still could ignore it. That would be crazy, but it could happen. A really, really huge remainder. Okay? You ignore the remainder, and the reason is this. If we wrote out our division statement in this situation, we have been told that x squared, we divided by x plus 1, so that was our divisor. We got x minus 1, and we got a remainder of plus 1. If I took my division statement and I wanted to get this by itself, I would have to divide the left side by x plus 1. But if I divide the left side by x plus 1, I have to divide everything by x plus 1. And if I divide this side by x plus 1, well, this would just become x minus 1, because there it would cancel, and I'd be left with this. And oblique asymptotes, like horizontal asymptotes, are telling us what's happening at extremes. So as x goes to infinity, can you see that this part in the green box is going to be 0? So what are we left with as x goes to infinity? We're left with what's in the red box, x minus 1. Explaining why that's your asymptote. Because as it gets closer and closer to infinity, it's going to get closer and closer, but not exactly equal x minus 1, because there's always this tiny little remainder that's left. So, to find your oblique asymptote, all you need to know is you can use synthetic division. You can ignore the remainder, just your answer is your oblique asymptote. So with that in mind, we can go to example 2, and the steps are still the same. We follow the steps. So people that like steps, you're going to like this unit, because once you got those steps down, you're going to do that for every single graph. And your graphs are going to all look different, but you're just following the same steps every single time. So to start with, we're going to factor x plus 7, x minus 1 over x plus 2. A non-permissible value. X can't equal negative 2. Is it going to be a whole or a vertical asymptote? Does it cancel out? No. So we have a vertical asymptote at x equals negative 2. Next, step 3. Do we have horizontal asymptotes or oblique asymptotes? Degree is bigger in the top. We don't have a hole, so we have an oblique asymptote at, well, how do I find that oblique asymptote? I use synthetic division. So 1, 6, and minus 7 divided by x plus 2, so minus 2 in front. Bring down the 1, multiply, add, multiply. Ooh, look at that. Remainder of minus 15, which you can ignore. Your oblique asymptote is going to be at y equals x plus 4. We have enough, we can start graphing this already. So my vertical asymptote at minus 2. My oblique asymptote has a y-intercept of 4, a slope of 1. We can label this x equals minus 2, and this as y equals x plus 4. That's step 3, figuring out your horizontal or oblique asymptote. Now we need intercepts. So again, I always start with my y-intercept. I like to go back to my original equation because plugging in 0 for x, it's pretty obvious that you're going to be left with minus 7 on the top and 2 on the bottom. So that'll be minus 7 over 2, minus 3.5. So I can go to my graph. Minus 3.5. Next, x-intercepts. You see, it was really nice that we factored, because factoring it early, the only way a fraction's equal to 0 is if your numerator is equal to 0. And since we have 2 factors in our numerator, can you see that one x-intercept is at 1, 0? And the other one at negative 7, 0. As far as sections go, the vertical asymptote will split your graph into 2 sections. Even though the oblique asymptote breaks it up over here, it doesn't create a new section. Only the domain broken up by your vertical asymptotes gives you your 2 sections. Do we have any points in section 1? Yes, we have that one x-intercept. Technically, this is enough for us to be like, okay, it has to go towards this asymptote. Okay. It's supposed to be smooth. It's not supposed to have that little wonky bend in it. Yours was worse. But that's enough, as long as we don't go through any of these asymptotes and get closer to it. That's going to be that section. I guess probably if I started up higher, that would have been that would have been nicer. A nice smooth curve through that one point. Do we have any points in section 2? Yes. I'm feeling, these are my least favorite. I find that the graphs, something about that just looks a little bit weird, but feels a little off. But that's enough. We don't have to do any other nice points. As long as you, yeah, let's not look at that graph and dwell on it for too long. Oh, okay, so let's do, I'm just going to start B on a new page. I think we can finish it in time. Oh yeah, we already factored it. You see that it just flipped it on us. But now our non-permissible values are x can't equal -7 and x can't equal 1. And they are both going to be vertical asymptotes at x equals -7 and x equals 1. And in this situation, oblique asymptote or horizontal asymptote, this is group 3. The degree is now bigger on the bottom. So we're going to have a horizontal asymptote at y equals. Y-intercept at 0, 2 over -7. And x-intercept at -2, 0, which again feels a little bit weird because it's on the asymptote, but that's okay. So we're going to know at least this part. Oh, by the way, we have now 3 sections. This much I know. I know that it has to go through there and has to go down towards the asymptote because of that point. But we are going to need other nice points. We're going to need to plug in -8, something to get something in section 1. You might also want to plug in another point in section 2 because it could hit this and go down towards the asymptote or hit this and go up. And we also need a point in section 3, so you plug in 2, something. What are you going to find? You're going to find this goes up like this. So if we plugged in -8 into our original equation, I'm going to get -6 on the top and -9 on the bottom, which is positive 2/3. No, I get positive 9 on the bottom. And this graph would look like this. And similarly, when you plug in 2, you'll get this. So we plug in those other ones to get nice points, and we would finish our graph. Okay, questions for this one are 6 and 7.